Hi guys, welcome back to my channel, the Data Basic. In our last video, we had discussed about what are metadata tables basically, how can they be used in production environments to optimize the cost, to optimize the storage and whatnot, right? And further, we discussed about two types of metadata tables basically. One is the history one and one is the snapshot one, right? And this video will further explore the other types of metadata tables. We'll try to explore these three metadata tables in this video: files, manifests, and partitions. And then in the next video, we'll explore rest of the metadata tables. All right. So let's not waste time and start exploring this metadata table right on from now. Right. So files metadata tables. What does that mean basically? Okay. Files metadata tables basically means it helps retrieve detailed information about individual current data files within a table, enabling granular data processing, schema management, lineage tracking, and data quality assurance. We'll try to understand what each of these statements mean with respect to files metadata table from the below queries. Okay. So I've just run a select star statement upon the department upon the files metadata table for the department table, right? So I just select all the columns from the files table in the department schema. All right. So if you just look at it, what does it what does it say? Let me just rerun it again. So I'll just rerun it again, and it will help us understand that what kind of information does this files metadata table basically consist of. Okay, so apart from the direct running of query on this metadata table, I'll also try to explain to you that how does it help us in different optimization processes. Okay, for example, you might say that your but a particular partition has small files. Then what will you do? You'll try to basically merge all those small files, right? So and make them into a larger file. So those kind of tasks need to be done, but only when we explore that whether the small file issue is present or not present. All right. So I've run a select statement on this particular files metadata table. And if you just have a look over here, what are the different important columns that we need to look at in order to understand this metadata table? So first of all, let us start with the file path column. All right. Just have a look over here. We have 4 records. Okay. And what if you look at over here, we have one thing in common: business unit equal to technology, then business unit equal to technology. So it's written business units equals to, and then again in the last two records is business unit equal to sales and business unit equal to sales. All right. So what does this individual file path mean? It basically denotes each of the data files that we have. Okay. And we had partitioned, if you have gone through my last videos, we had partitioned our particular department table on the basis of business unit. And that's why there are two different kinds of business unit partitioning that has taken place. One is business unit equal to technology, and then is business unit into business unit equal to sales. All right. Then the next thing that has happened is it's 0001 for a business unit equal to technology, and then there's 000 like and 5 zeros, then 2 for business unit equal to technology. All right. Similarly, for sales, what has happened is for sales, you have this one. This is the second file. Okay. Oh, sorry. This is the first file 00012, and this is the second file 0023. All right. So basically, what is happening is these are the different data files that have been formed as we keep on inserting data into the table. All right. So it's just the file path that we have with respect to each of the data files in that particular table. Okay. And then what is the file format of those individual data files? It's all Parquet, right? Then it's all written over here. It's all in the Parquet format, correct? Then of course, we are able to identify the partition from the file path itself. But then what we need to understand is that we also do have a partition column over here. You can look over here. It's business unit equal to technology. Then business unit is technology. So for the first two partitions are with respect to business unit technology, and the next two partition are with respect to business unit sales. Right now, in each of these data files, if you just want to query on those data files, you will see that they have an individual count of 1. So 1, 1, 1, 1. And what we had seen in our last video, or in this video also, if you have a look over here, there are 4 records. Okay. Now, 2 are with respect to sales and 2 are with respect to business unit technology. That means that the first 2 data file with respect to sales, like the 2 records with respect to sales have got 2 data files, and the 2 record with respect to technology have got 2 data files. Let us just have run a simple query in one of those data files. Okay, we will just have a clear idea that what like uh, whether at all these data files consist of anything. Okay, so I just run a simple query. Select start from Parquet dot. This is basically a quick uh, you can say a code, right, to just query upon any Parquet file in the Databricks environment. So if I just run over here, run the data file query over here, query upon the data file, basically the first data file, which has basically in unit technology, you can see that we have got the department ID 4 record, and it's what department name is enterprise, business unit is technology, and manager ID 7. And of course, I told you that this one is the second record or the last inserted record within the particular table for business unit equal to technology. And if you look at over here, you can just have a look. 1, 2, 3. These were the initially 4 inserted records, and fourth department ID which was inserted, okay, had manager ID 7, business unit as technology, and the department name as enterprise, right? So yeah. So if you just query upon those Parquet data files, we'll able to get those individual records. So those individual records have got their individual data files, right? Now the next thing, we have understood about the record count thing. Similarly, if you query each of these data files, you'll see a record count of 1. Okay. Now, the next thing, file size in bytes. So the file size in bytes for those individual data files is this much. So the last data file that we inserted has a file size of 1301. And then for business unit technology, and the first data file for business unit technology had 1 of 64, right? And then the individual data file for sales, one of them is 1015, and the other one is 1987, right? What does the column size field mean? Basically, it is used to identify the column sizes of those individual columns. Now, each of those individual columns have got their own column IDs. So the first column ID, first column has a column ID of 1, the second column has a column ID of 2, the third column has a column ID of 3, and the fourth column has a column ID of 4. We had discussed these things in our previous videos when we discussed the manifest list, manifest files, right? When we discussed about the metadata files, basically prior to the metadata tables, we had discussed those things, right? So now just let us have a look over here. What is the main difference between the first record and the second record? Okay, you can see we have 4 column IDs in the first record, right? And we have 3 column IDs in the second record. Now, what is the reason for that? So the second record was initially inserted into the table when we inserted values the first time into the table. Okay, and when we inserted values the first time into the table, we have 3 columns basically. All right, so you can see 1 2 3 1 2 3 and 1 2 3. So the last 3 records in the files metadata table have column IDs only 1 2 3, but the first one has basically column ID 4 also. That means we later on alter the table, which further created another column with a new ID. All right, so it has a column ID 4, and what is that column? Basically, that column is manager ID. All right, and since we have inserted value into the table for manager ID, its value is 7, right? And that's why there is a column size associated for that particular data file, for that particular column, right? So one column ID 1 has a column size of 47 bytes, column ID 2 has column size of 57 bytes. So if I say that what is the column size of the third column, or the what is the column size of third column? So basically, that means what is the column size of business unit? All right, for this particular data file, it's 57 bytes. So the column size of business unit, which is basically ID 3, is 57 bytes, right? And then you have column size of column ID 4, which is the manager ID, which has 47 bytes. You see, it's the manager ID, right? We have inserted a particular value into this table. That's right, there's a particular value associated with it, right? Then value counts. That means each of those columns in that particular data file has how many counts? One count, right? Across all the columns. So 1, 1, 1, 1, 1, right? Prior to this data file, we did not have any column called manager ID. So we have three column IDs, 1, 1, 1, and then 1, 1, 1 and 1, 1, 1. So as discussed, we have a, an individual count or single count in each of these data files, right? Then null value counts. Do we have any null value? If you just query upon the table, we of course will see we have a null value, right? But if you look at this data files, it's saying that 1 to 3 has got no null values, that's zero null value counts. Then again, 1 to 3 has zero null value counts, then 1 to 3 has zero null value counts, right? But we query upon the table, a person at first might judge that no, these data that there are null values in those particular columns, in that particular column, right? Why it's not being shown over here? It's because we just altered the particular table later on, all right? And then we inserted value into this. That's why when we inserted value into this, it has no null value. Suppose if the manager ID even had null value in this particular table, in this particular record, right? Then we would have observed that the null value count for column ID 4 is 1. So that means the initial three data files are with respect to the scenario when we did not have the fourth column, basically the manager ID. But the first data file is with respect to a scenario where we had altered the table, all right? And then we had inserted value into that particular column. That's the no null value counts. And then we have the alien value counts column. All right, we do not have any alien values. That's why it's an empty curly braces, right? And then finally we have the lower bound and the upper bound. All right, what does the lower bound and upper bound basically signify? It basically signifies that within that particular data file, what is the lower bound, and within that particular data file, what are the upper bounds? Okay, we had discussed previously that these lower bound and upper bounds are actually the base 64 encoded values for that particular data column in that particular data file, right? We had discussed about those things, and we had also uh, decoded these values and just looked up that what are these values, right? Now, since a particular data file has got only a single record, it's very logical to think about that the lower bound and upper bound should remain same, right? So you can see the lower bound and upper bound for each of these data files is all same B, and then 5A's, and over here also B and then 5A's. Similarly for the fourth column ID, it's BW, then 4A's, and it's also VW and 4A's. Similarly, if you look at over this particular lower bound, it's all same again for the lower bound and upper bound in that particular data file, right? So each of these data files has got a single record. That means then the lower bound and upper bound remains same. Now, how does this help the query engine? It basically helps us prune out the records. Okay, it helps us prune out the records which are not required for our analysis or our output, right? Now, one important thing to note over here is that just think about this scenario. Each of these individual data files has got only one record. Is this optimized? No, right? So here comes the optimization part. So looking at these metadata tables, you will basically be able to understand that how to optimize, where to optimize, right? Then another thing that you should know actually is the split offset ID. And later on these columns, maybe if we make use of it, we'll understand, or not later on, or like we'll just let go of it, right? So split offsets, basically it's a concept in big data engineering. So when you particularly split a particular file into multiple for the chunks, okay? So how do you decide that? How does the query engine decide which file to read in which scenario? So the first file has got, you can say, the 0 to 4 bytes record. Then the second file has got 5 to or 4 to you can say 8 byte records, right? So it particularly it's decided, right, that how many byte to how many byte is the from how many bytes to how many bytes the particular data file has got records for, right? Now since we have got one data file, so it's 0 to 4 basically, right? So 0 to 4 bytes. All right, now this is a simple query that we have run. Now, suppose if someone later on asks you that, brother, can you please help me find out those data files which require rewriting? In this scenario, what did we see? We saw that the individual data files have actually got only one record. That means they might need rewriting. Okay, but How do we decide the rewriting path? That's upon us. For example, what I've done, find the partitions to rewrite. It's the comment that's written. What I've done, I'm trying to find out those files which have got lower, you know, file size than the average file size across all the data files. I'm just trying to find out that. Just now, let us see if it's first of all, like if it's working or not. Okay, select partition, count star, average files in byte from depot. This one. Okay, I think, and let me just run this file. Uh, let me just run this query, and then let us see what is happening. So this kind of query will help us find out that what is the average file size across all the partitions, right? You see, average file size is this much. Okay. Now from here, what you can probably do is you can probably find out that what you just put that in put this in a particular CT. Okay. And then you find out the file size in bytes, which is less than the average file size. Okay. Right. We're getting it. So you just select star from CT, select star from CT. You maybe join on the partition. Okay. The partition is over here. And then you just query that file size. Okay. You put this in this entire query in a particular CT, and then you write it, select star from CT, join default the department dot files on partition on files dot on this one dot partition equal to um you know the ct dot partition, where average file size is greater than file size in bytes. You just will be able to find out the partitions to rewrite. Okay. So this is the way in which you actually can optimize these things. Similarly, if you find if you want to find out that what are the null values or the missing values in a very lightweight manner, all right, what will you do in that scenario? You don't want to scan the entire table. Whenever you scan across the entire table, there's a cost involved with it. It's not free, right? So just if someone asks identify the null values or the missing values, and you want to do it in a lightweight manner, what will you do? Okay. I think I had this query ready for me. Let me just it's in June 29, it's June 26. Let me just find out that whether I had the CT written for me previously, where I would be able to find out the values or partitions to rewrite. Not yet. Okay. All right. Maybe like let's just not waste time upon finding out this. Okay, I just gave you a basic idea that what to do, and I'll just rewrite the CT and tell you. But the basic thing is you are able to find out the average file size, right? By running this query. Now, basically, what you'll do, you'll find out all those all those files which have got file size less than the average file size across those partitions. You'll be able to find out how. You'll just join this particular. You'll put this in a particular CT, and then you will just join with this particular department with this particular files metadata table again on the basis of partition, and then you will write a condition where file size in bytes is less than average file size. I'll put this query in my notebook that I attached. All right, and then the next thing, identify the null or missing values in a lightweight manner. What I'll do, I'll basically not scan across the entire table. I'll just run this particular query. Okay, let me just comment this out, and let me just run this query. What is happening? Run the selected text. And then if you just run the selected text, you find that there is no null value. That's what you have seen in our files metadata table, right? So it's all done. So this is a lightweight manner in which you'll be able to identify your null values. You do not need to scan the entire table, because that's where the cost starts taking up. Like I'll tell you a scenario, like in a project, what had happened. Like basically in Databricks, the serverless, right? The SQL warehouses are serverless, and then the PBA people or ourselves, even what we used to do, that since it was an instant, it was those there were those clusters where the server got up instantaneously, and we did not need to waste time upon waiting for the cluster to get initialized. What happened is that the cost increased a lot, okay, because the people were scanning upon a table where the records were almost 24 billion, 30 billion, or then 7 billion, right? And that's why, when since the table was scanning upon since we are scanning upon the entire table just to find out null values, the entire cost increased. And the cost for that particular day was actually based upon these queries only. It was close to I think so, like we're doing some kind of analysis, and it was close to $1,000, right? It's not required, correct? You can just query upon these metadata tables and then find out which of these columns have got null values. Okay, like similar kind of analysis we're doing. It was not related to null values, but yeah, you can utilize these metadata tables for your file level analysis, data file level analysis, basically. And then if you find out that what is the total file size in bytes, okay, for this in that particular table, it's 43667. So it's the entire file size across all the data files. It's 4367 bytes. Okay, so you'll be able to find out that how much space, or how much is the file size in bytes for my entire table, for the current data files in my entire table. All right, so yeah, that's how we explored the files metadata table. Hi guys, sorry for the interruption. Actually, I had to cut the video short because I wanted the topic to be much more crispier and actionable from your end, so that you can uh, go in an in-depth way into these topics, so that and you do not feel overwhelmed, right, while going through these topics, because these are the topics which you need to learn to work in production environments, and I want you all to know about these topics, right? So in this video we have kept it till files metadata table, because there are a lot of things to explain in this. In our next video, we'll further explore about the leftover metadata tables. Like, I think we'll require two more videos in order to complete this entire metadata table topic. Why I'm trying to explain this entire metadata table topic in a very um, detailed manner. The main reason is because you need to know about working in production environments. I've seen multiple people not knowing how to work in production environments in the most cost effective manner, right? And you, as newest data engineers, or people who are already working as data engineers, it's very fruitful for you people if you like do not feel overwhelmed by the length of the video, and then you also get to learn each and everything in a detailed manner. Thank you. Thank you so much for having that patience.